Welcome to myprojectbazaar.com.
Now we discuss about the product for Union, a unified intrachip optical network for chip microprocessors. Then we discussed about the abstract for the product. Modern computing systems have become increasing complex to satisfy the growing performance demands by applications. As the number of transistors available on single chip increase, the billions and chip processors has become an attractive platform delivering high performance with limited power budgets. In a complex CMP systems, the communication efficiency among and with chip is very important for overall system performance. If the data access latency becomes too large, the processing codes would spend much of their time simplifying wasting of these processing powers. As the modern computing system become an increasing complex, communication efficiency among the inside chip has become important as the computational speed and individual processing cores. Traditional to maximize the design flexibility, interchip and intrachip communications architecture are the separately designed under the different constraints. Jointly designing the communication architecture for both interchip and intrachip communication goods, however, the potentially yield better solutions. In this paper, we present a unified intra and intrachip optical network called Union for the microprocessor. Union is based on the recent processing in nanotechnologies in connect not cores on a single microprocessor but is a multiple microprocessor in a system. The Union process mainly based on the NOC oriented process. The NOC oriented process mainly used for network on chip for the data transferring into each and every router placements and connectivity level. Network on chip is a new methodology for system performance and system data transferring design process. NOC based system accommodate the multiple asynchronous clocking that may of today's complex of SOC designs usage. The NOC solution bring a networking method to on-chip communications and claims roughly a threefold performance increase the over conventional bus system. So we implement the network routing process using the genetic optimization technique algorithm. This algorithm mainly to reduce the path analysis for source to destination data transferring process and to design the fault analysis process in our architecture for overall NOC designs.
Next, flow diagram for the product. The input data bits to transfer the routing process. The routing architecture is mainly for the four-way communication. Any type of source to apply the input and any place to destination for to allocate the routing process. The routing architecture with connectivity based on the mesh topology based connections. All the routers connected to the all router positions, and the genetic algorithm is to applied by the routing architecture designs. This the routing architecture designs to the applied the regular route wheel to allocate the parent node allocations. Then the parent node allocation to apply the child node allocation part to the next level. The next level to mutation and crossover functions. The crossover function to apply the child nodes, the different child node function to allocate the mutation function, and the fitness values to analyze each node functions and check the final known results for fitness functions. Thus the genetic algorithm fitness results to the previous and present results are applied to the genetic process. Thus the shortest path is allocated by the two allocation conditions. Then the genetic process to shortest path minimization to be occurred. Then the shortest path to be applied for the process. Then to analyze the fault analysis process for each locations, and to fault analysis condition to mainly based on the previous and present path data transferring technique, and to transfer the positions to check the fault analysis conditions, and to fault analyzing process to be mainly applied to the two transferring for the each node, and to allocate the additional temporary storage node to previous results. Then the present result is going to the one additional temp nodes, then two additional nodes to process the overall node, then the fault allocation to be clarified for the NOC architecture designs. Finally, we run the output for the product. First of all, we run the Xilinx IEC project. Then to select the routering function and to select the stack behavioring function. The stack functions to be mainly focused by the genetic algorithm process. The router function is separately to the router architecture results and to process the how to process the router functions and source and destination location to find the NOC architecture. The genetic process architecture consists the regular routing wheel functions, then the crossover functions, and to the mutation process, then the fitness functions, and to finally allocate the fault allocation functions. These are developed by the behavioral language, then to select and simulate behavior model. The process is completed successfully, then to create the iSIM project navigator. This is the simulation process. First, we apply the input for spin and reset clocking function for our genetic algorithm process. Then to set the spin 1, then the reset 1 positions and the clock to initial 0 positions. Just run. Then to change the spin, reset and the clocking positions. Then run. Then to activation clock is to be applied by the simulation results. Then apply, finally get the fitness output for the previous and present nodes. These are the shortest path analysis for our architecture. The fault enable function is 0 to the fault location is to find the 0 positions. Then the temporary storage data transferring nodes are to apply to the Z1 and B1 results. This is our the simulation result for our the NOC genetic processing results. Then implementation to select the fitness function and to create the RTL schematic diagrammatic representation. This RTL diagrammatic representation is used to the what are the logical blocks presented in our SOC architecture. Then add and create schematic. This is the our logical blocks for our overall architecture functions. This is the logical structure to be placed by the architecture result functions. This is the technological diagram. This is the same process. The technology diagram is used to represent what are the lookup table and how many wire connections, then how many flip-flop pairs in placed by the overall NOC architecture. Then go to the design summary process. Then select the synthesis report. The report is used to area and timing calculation for our NOC architecture. This is our the area calculation for our NOC architecture, slices LUT lookup table, then bounded input output function. Then the timing calculation for our NOC architecture, this is the minimum period of timing and the frequency, clock frequency. It's directly proportional to the speed processing. Then the latency level to count of after and before clock functions. Is the timing and device utilization function is used for based on NOC architecture designs.